Hello everyone. So today I'll show you a use case dealing with parameterization of connectors. So in fact I received one request recently from a user who wanted to parameterize his spot welds, especially ACM general spot welds for HyperWorks. So my first idea was to orient him to propose him to use the Design Explorer, as in the Design Explorer you have some connector variable which you can use, and if you use the connector selection, you can see that you have several attributes that are available, at least two attributes that are available for the spot weld, which are the tolerance and the diameter. So one of his feature of interest or parameter of interest was the diameter. But the Design Explorer does not allow to get access to the other parameters he wanted to deal with. So let's have a look at these parameters just for the purpose of the video. And there is this option about using RBU3 radius, which allows to give some extra information, such as the radius of the RBU3 and the RBU3 radius method for defining the. Sorry, let me expand a little bit the window. So the RBU3 radius center, and there is option also for the normalized RBU3 weight factor. You can even normalize if needed. So how to quickly go parameterize such study so without the Design Explorer. This means we'll go with HyperStudy, and then the idea is to automate the process and with the shortest effort possible. So for doing this, the first step that I did was to look at RBU3 radius. Let me change to one value here. Let me change here to cluster center. Let me change RBU3 weight factor, and let me re-realize my connectors. Now let me go to the HyperMesh journal file, the command file, and let's see the command that were used. So I used the radius of 0.3333 in order to easily retrieve it into my my command file. So this is my first line. So let me open a new file. So this is the first one. Then I have a second command, which is for the RBU3 radius center, which is this command. Okay, and I have this command, which is for defining the RBU3 weighting factor. So these are my possible options. And then what I need first, because if you look at this command, we have the star set value, connectors, and it requires a mark of connectors. So we need the command star create mark connectors 1, which is the ID of the buffer. So the one here should be the same that the one that you see here. And if you look at the command file, it just stores the row IDs of the connectors. Here, I don't want this information. What I want is to have the connectors by configuration, knowing that this is the ACM general configuration. So what I can do is contains value, use the filters contains value, and I think it's CE underscore FE config. I do not know them by heart. I did some tests in HyperMesh in order to retrieve the good one, and it's ACM space general. Close parenthesis. So if my memory is correct, let me go copy this line, put it in HyperMesh again, view TCL console, Control V, no change. Okay, so there's something wrong in this. Let me go into my other file which I created, the config name. So if I pick it again, this time that should work. Okay, 3 connectors added. So now I can play with this value. So this will allows to update connectors parameters. Now, what about the realization? The re-realization, let's go back to command file. And we have this star serialize, which also requires the connectors, the create mart connectors. So let's paste it and let's replace the first line by this one again. Okay. So realize the connectors. So this will be update connectors parameters. Keep the same wording. Then we have the export FE model to take into account. So let me go to File, Solver Interface, OptiStruct. Let's wait for the pop-up to... Oh, sorry, it was an export, OptiStruct, Solver Deck. It was not changed in the interface, and let's save it as spots.fem, just for the sake of the presentation. Okay. So now if I go to, so I can export it. If you need to change the parameters, you can change it. And then if you go back to edit command file, then you have this star create string array. By the way, you could set all this line. Starting with create string array should be enough for my example here. And let me paste this information here. And there is one last step which I need to bring in the macro, which is import the FEM file. So let me go to File, New, don't save, and let me File, Open Recent, open Solver Deck, and let's take the spots.fem. And once loaded, let's go back to edit command file. And still this create string array with the if input data 2. Okay, so this I can copy it here. So let's say file, save as, and I will save as TCL. Connector parameterization.tcl. And now I see my command, I have the value. So this looks fine. I have a macro which I can start to use. That being said, there are still some points which I need to change in order to make sure everything runs smooth. The first being to change here, you see that I have a hard-coded installation path. I need to replace it. So I have one statement, which is this one, hm app info specified path template dir, which I will copy, and I will replace the beginning. If you look at this statement in HyperMesh, it allows to get to the installation program. And I should have another one which may help me. HM scripts here, I think. So I think I HM scripts underscore dir. Okay, which will be required just because I want to make sure file solver interface. I want to make sure when I load my HyperMesh model that HyperMesh automatically goes into the OptiStruct profile. So I will force HyperMesh to go in the OptiStruct profile, and then if I open again the command file, I will need the scripts directory because I need these 2 lines at least. So load OptiStruct profile, and I need one here with the templates here to go for the templates, and I need the other one to go with the scripts. So does it contain the scripts? It contains the scripts, so HM scripts here. HM underscore scripts underscore tier. And by doing so, this macro should work. So let me save it. Now let me check before going to HyperStudy. Let me try this macro. So let me file, load, script. Let me run this parameterization. Okay. And there's a wrong copy paste somewhere. There is a star missing here in my copy paste. So always good to test in HyperMesh without doing anything in a HyperStudy. Your macro route has really to be working in HyperMesh first. So load, script. Okay, so what's wrong here? Templates. I think I did one mistake here. I need to remove the templates statement, and same here, I guess, in order to be correct. So let's repeat it. So you may have some back and forth just to make sure. If you thought too quickly as I do, so file, load, script. Okay, I could have add a statement to say, okay, I want it yes, but in HyperStudy purpose, this should not occur. So everything went fine, and if I go to my folder, I see that the FEM file just has been rewritten. Okay, so now my macro works. How to adjust it for HyperStudy? So now let's go to HyperStudy. 22.1. So what I will, the parameterization will be done not on the HyperMesh file, not on the FEM file, but on the TCL file. To me, this seems the most suited approaches. So let me start my study. Okay, sorry for the time. It seems HyperStudy is freezing a bit. Okay, so I'm selecting this folder. Okay, now I want to add one model, which is a parameterized file. Okay, and what I want is to pick the TCL as parameterization. So yes, I would like to parameterize it. What I want to parameterize is this value, which is the radius, RBO3 radius. Okay, I want to also select this parameter, which will be a string. So I can choose between cluster center and, if I go back to one of my statements, each RBO3. And the norm distribution here, I can create parameter and same norm dist3 or inverse dist. Just make sure when creating the name that I think for this one I can keep %s. Okay, no, so I need one. Okay, let's no. Let's keep it this way, and we'll check if that works later. So okay, what I want to do is to run a HyperMesh script first. So it can be HM batch, it can be HyperWorks. And what we'll do is to use -tcl and $file path, which is my resource, my connector parameterization.tcl. So once the setup is done with the TCL or the TPL parameterized file being generated by the HyperStudy editor, which populates back the TCL, solver execution batch to a HyperMesh, and the solver input argument, there is still one point to be modified in the initial file in order for the macro to run fine, because HyperStudy will populate some subfolders, and we need to take this subfolder organization into account for dealing with the path, especially in the TPL or TCL. So what I added into the TCL is one statement for defining the working directory, which will be the file where the script, which will be the directory where the scripts will be populated for each iteration. And this will be also the path where the HyperStudy will export here the FEM file. Working there will export the FEM file. And then by using some TCL statements, I defined a second directory, study directory, in order to point to the root directory, because I wanted to avoid to copy each time the FEM file in the working directory. So I had to define the location, just take the path up prior to approaches. So for this, I use this statement here, which allows me to find the location of approaches in the path and to cut everything which is before approaches, just to keep the root part of the study directory. So now I can click on OK. If I go to next, I retrieve my variables, and if I go to the right step, I can delete, and if I look at my directory, I will have my file populated in the correct folder. So now there's the last part of it. We can execute then in order to make sure that the execution works fine. Please make sure to look at the std out, std error, and command 1.tcl if for any reason the spots.fem is not generated. So here we should have a spots.fem. Okay, it's correct. And now let's add what is necessary to run the OptiStruct. So for this, we need to add one model of type operator. We'll ask for OptiStruct as solver. Define some arguments. So spots.fem minus nt4 minus cur in. And there is a last step, which is the model resource. I need the spot.fem to send it into M2 because the script will work on the subdirectory M2 from the operator 1, the OptiStruct script. So let me right-click on M1, add output file, and pick the FEM, open, and then let me right-click on operator M2, add link resource, and let me pick spots.fem. Sorry, I did it already once, so I can remove one of them, remove resource, and here I have my link spots.fem, which is copied. And then if I come back to the test model, I can write, so in the directory I should retrieve spots.fem, and then I can execute. So OptiStruct has been started. I didn't validate my FEM model before running it, so OptiStruct starts because I got this .out, but my model was not complete, so it ends with an error, but this is not linked to it is linked to the fact that I didn't completely define the FEM file. And so my setup for HyperStudy is done.